one. Really appreciated this. Just to contextualize the specific problem for all the colleagues, in this particular body of work that we engage with at the University of Pretoria, with Vatis Ranted, as well as with myself, the presentation that I'm giving now is a broad overview of recommendation systems within higher education, but this leads it and lends itself to a large body of work that translated into data collection frameworks and data collection strategies that have to be deployed to understand students a bit better. And within the context of this work, and the work we engage with is predominantly focused on reinforcement learning and autonomous self-learning systems that can study humans and that can augment certain human-based processes within the context of higher education. Now, before and for the purpose of this presentation, I'm not going to go into anything technical. I will just give sort of high level, very basic overviews, but I mean, if the level of detail is required, it would be more than welcome to ask questions on that, but we can take it offline. But to orientate our minds toward this problem, I just wanted to frame it in a very specific scenario. Imagine there's a mouse and the mouse falls into a tank of rice. And the mouse is very delighted. The mouse is happy. The mouse looks around and finds no issues, finds no threat. The mouse starts eating the rice and falls asleep. And it keeps repeating this process until eventually the rice runs out. And by the time the mouse realized that the rice had run out, it was stuck at the bottom of this empty tank. And it realized that it couldn't get out anymore because the mouse itself was so focused on what was in front of him and not necessarily what lay ahead of him. And it's with this concept and this construct that I would like to start the presentation. You know, just to point out that I'm not a particular Luddite that focuses on critiquing the algorithms, nor pointing out the fallacies like Fabio had mentioned. Are we trying to fix human problems with technological solutions? But what I am trying to illustrate and point out is that we can't continue using some of the data collection strategies that we had been using in the past for the way of the future, specifically in the domain of higher education. Now, in a broad sense, recommendation or recommender systems are a type of filtering information system. I think I don't need to go into detail. A lot of examples were given about Google, Facebook, YouTube, etc. And depending on how they work, will be determined by what type of filter they are. There are many more different types of filters, but you get filtering systems that filter on the basis of content. You get systems that filter on the basis of what people rate and top end recommendation systems, what people rank, what the collective perspective is of a particular concept. If a group of people with a certain demography, for example, chooses a certain thing, then it would recommend on the basis of that. Now, in a very high level overview, one would have quite a large database here. And depending on what type of filtering mechanism is used, it will use a combination of different methods, which is the most preferred method. If we can look at the Netflix challenge and the Netflix algorithms that are being implemented, it's actually a combination of different methods. But at the end of the day, you would use a large data bank, some information about a person in a specific domain or with a specific problem, and it would recommend a particular type of object. This representation was well illustrated in a paper by Albert Eckert in 2009. And what was really powerful about, and is very powerful about this idea of recommender systems is that recommender systems typically form part of a larger group of algorithms that you can put it into. So for example, if you look at the incorporation of recommendation systems or recommender systems as a layer within reinforcement learning, so recommendation systems within reinforcement learning algorithms, you can see that if you can give it a relatively low or high signal, you can get very interesting results on that part. So this type of filtering and dynamic filtering has its applications, and it's very important. Now, in the context of education and in the problem that we find with recommendation systems is that you sit with this issue of the fairness component. So the fairness component and the equity element that you see in algorithms could translate into a variety of ways, but it's best and most simple in its most simplified form. If two people buy a particular book, okay, the book could be a textbook from a subject. The one person could buy it because they need it to study a particular subject matter. The other one could buy it for leisure reading. Now, This means that both users would buy the same item, but the context behind why they're buying the item is different. And therefore, if you collect data without this type of contextualization, you would lose that context and you might create a mass, well, as it currently is, a mass confirmation bias when it comes to particular items. This doesn't seem like a dangerous concept right now, but if you consider that it could be applied to the education context in the terms of interventions like seeing a student counselor or perhaps giving someone academic advice, then it might have detrimental effects if you recommend the wrong intervention for the wrong problem. So this leads us to the first part of the framework, is just thinking about an outline. Outline one is if you want to study information about a student, then you would want to get information at the end of an undergraduate academic journey. Now this becomes exponentially more complicated when we think about postgraduate students. So for the purpose of this entire presentation and the paper as well, we just focus on undergraduate students. And it must also be noted that it is a very specific cohort of undergraduate students. This wouldn't apply to all of the study fields that are out there. But the general, in a broad sense, what you want to do is you want to collect 3 different types of information contextualizing into students. You want to collect information with undergraduate students who repeated an academic year due to failing a particular course or something. You also want to isolate and stratify the data into students who changed their degree course. And you also want to stratify it according to students who did not change the degree course and who graduated in record time. And what you would need to do is you would need to create or collect survey or user-based data that is contextualized for each of these 3 scenarios. And this means that student choices and user preferences are quite important to the first layer of the data collection strategies. And the second thing I want us to briefly think about is you would need static information about the student or the user. You would need dynamic information about the user, and you would also need static and dynamic information about the domain, meaning the curriculum. So what this means is that there's some information about the users or the students that won't necessarily change over time. There is information like the user's preferences or the student's preferences that will change over time in their interests. And then obviously institutional policy changes, curriculum changes, content changes within their degree or subject matter. It needs to be able to capture all of this information so that you can create some kind of user-specific pathway that you can evaluate. So information about the students, the changes over time, and the curriculum is important. Then we sit with this outline number 3, where we need to calibrate and contextualize the information related to the different levels, academic levels of an undergraduate student. So we have the 3 levels: entering students, students in this intermediate phase. So this could be 2nd, 3rd, 4th year, etc., and then students in their final year as they leave. And so the calibration has to stratify the information according to this. And with each level and with each layer, you would need to create retrospective, hypothetical intervention-based data from the users themselves. So for example, at the end of a first year, you would identify by asking a student or by a system-generated intervention, ask a student what type of intervention or what challenges did you face. Then you would ask, well, what do you think would have helped you? And how do you think it would have changed the course of what happened in the year versus what actually happened? And in terms of the data collection strategies. Now, the problem with this, and this is very important, is that you immediately can see that there's a lot of ethics and a lot of red tape over what information should be routinely collected, what should be collected on the premise of ethical clearance, what should be collected that users are aware of, should there be information that is just routinely collected into a system used into this? And these are fundamental and complex questions. But in terms of an algorithm perspective in its implementation, if we want to get the best and most holistic information in this domain, this would be a viable strategy for that. So the timing of the interventions are very and contextually relevant. And so if we go into the framework itself, if we want to collect meaningful information on as for student recommender systems, as well as in higher education institutions, we would need user information. We would need to collect retrospective data from the user's perspective, so where they evaluate themselves. We would need some kind of academic journey contextualization. This would mean that for each degree and each particular course, there's some calibration at an algorithm layer, at a data science layer, that would need to take place in order to add it technically to the entire implementation of whatever such a system might mean, which means that you get these two layers. The one is, a set of questionnaires and surveys on what intervention could have potentially hypothetically assisted the students and what this hypothetical outcome could potentially be in relation to the type of data or the ideal situation that the student would have. Whereas on the inverse of it, I'm almost done. Thank you so much. Questionnaire on why the student failed and the actual outcomes of that based on what they had done. This would feed into a big database, and you would triangulate this information with what the student actually does in terms of the engagement with the online learning system, the learning management system. So this research was important because it outlined a fundamental step that's required to establish such the groundwork required for data collection strategies. And what is very important is that this framework is required in order to create a set of comprehensive data collection instruments. Now, once these instruments are in place, we would need to do appropriate subsequent evaluations in order to establish, now that we've collected the correct data, what type of filtering mechanism would be best for the education context. But until that time, we would really need to look into how we design our surveys and questionnaires and how we use it for the data required in systems like this. So I just, obviously it was well referenced. I just wanted to say thank you to the Data Science for Social Impact Group at the University of Pretoria, University of Witwatersrand, and the work that we did with Dr. Bukosi Marivate and Dr. Benjamin Bosman. Questions?